What's up? Welcome to Models and Agents, episode 92 for June 25th, 2026. Your daily AI briefing. Lots of news to walk through. Let's start with what actually matters. GPT 5.5 Instant now handles intent and constraints more reliably while rolling out to all users this week. OpenAI released an updated GPT 5.5 Instant that improves intent understanding, complex constraint handling, and recommendation quality. OpenAI also announced its first custom AI chip, Jalapeño, built with Broadcom for ChatGPT and agent workloads. Several new archive papers introduce agent evaluation frameworks and test time adaptation techniques that address real deployment gaps. The updated GPT 5.5 Instant better interprets user intent and adapts responses accordingly, while handling complex constraints more reliably. It also produces more useful and cohesive shopping and local recommendations. The change targets OpenAI's most used model and is rolling out today to paid users and tomorrow to free users. Builders working on recommendation or multi-constraint chat flows should rerun recent prompt sets to measure reduction in clarification turns. Watch how the update interacts with agentic workflows that chain multiple tool calls. This development builds on the frontier models coverage from episode 90, where closed models traded capability leads, and it moves the open question of capability gains versus cost trajectory by tightening intent handling on the model developers already use most. OpenAI designed and produced its first purpose-built AI chip in partnership with Broadcom for LLM workloads powering ChatGPT, Codex, the API, and future agent products. The move expands OpenAI's stack from models to silicon to support larger scale. No performance numbers or availability details were released. Infrastructure teams should monitor future announcements on token cost impact once the chip enters production serving. This ties into the AI, compute, and inference thread from episode 91, where custom silicon was tracked as a lever on the inference cost curve. Akishoff Yael Lida is an 8 billion parameter mass diffusion language model trained from scratch with fully bidirectional attention on 12 trillion tokens and a 25 billion token instruction corpus. It improves BBH by 21.6 points, Act Challenge by 14.9 points, Math by 14.5 points, and Human Eval by 16.5 points over the prior LLA-DA version. The model remains competitive with Qwen 2.57 billion despite its non-autoregressive training. Teams exploring diffusion-based language models should test the released weights for tasks where bidirectional context helps. This update narrows the open weight models gap discussed in episode 90 by showing non-autoregressive approaches closing in on standard autoregressive baselines. A new dataset of 32,534 double-marked GCESE mock exam responses across 328 questions shows top LLMs agree with examiner consensus more closely than examiners agree with each other. Agreement holds on subjective English essays and messy handwritten math scripts. Model size shows little discrimination in agreement quality. Education and assessment teams can now evaluate automated marking pipelines against this frozen, real student distribution. Agent Odyssey procedurally generates open-ended text games with rich entities and long horizon tasks to evaluate test time continual learning. The framework measures game progress plus world knowledge acquisition, episodic memory, exploration, action diversity, and model cost. Even top agents remain far below human performance, though stronger base models improve results and short-term memory helps multiple paradigms. Agent developers should run their systems on the generated games to quantify meaningful horizon length. This continues the agents and tool use arc from episode 91. Where reliability of long horizon agents was flagged as the key open question. BiPace replaces observation hash grouping with cosine distance clustering in the actor's hidden state geometry and adds action-conditioned peer baselines for advantage estimation. On ALF World with Quen 2.57 billion, it raises success from 90.8 to 97.1. On the 1.5 billion variant, it reaches 93.5 versus 86.7 for the prior GigPO method. Overhead is 11.3% of a single training step. Agent teams using stepwise group-based RL should test the open implementation when credit assignment currently produces singleton groups. Hybrid IR combines graph-based retrieval for structured knowledge with dense retrieval for fine-grained semantics and adds an iterative retrieve-reason loop. The dual-path design first pulls structured associations via graphs and then refines with dense vectors for local semantics. An iterative loop alternates retrieval and reasoning steps to recover details lost in single-pass methods. It targets complex medical QA where single-path retrieval loses either global associations or local detail. Experiments on 3 standard medical QA benchmarks show effectiveness. Medical RAG teams should compare it against their current single-path setup on multi-hop clinical questions. The author built a frozen 240-task eval set sampled from real production traffic and routes every candidate model through the same prompt sequence via GPT Proto. Results show the leaderboard winner often differs from the model that wins on the user's distribution. Gaps between first and second place shrink dramatically on the private set. One model that looked strong on public benchmarks had a long-tail failure mode that would have caused production incidents. Another candidate reversed its ranking entirely once the traffic distribution was applied. Teams should replicate the approach of freezing and versioning their own usage distribution before trusting vendor-reported gains. A test-time adaptation method using semi-supervised learning on unlabeled inference time samples maintains robustness when supervised detectors encounter adversarial humanization, new LLMs, or temporal drift. The method clusters recent inference examples and generates high-confidence pseudo-labels inside each cluster. The commercial pangram detector drops to 24.1% on adversarial AI text, while the TTA approach reaches 90.5%. Code is released at the linked GitHub repo. The adaptation adds 1 forward pass per batch and runs on a sliding window of recent samples. Detection teams facing distribution shift should evaluate the semi-supervised adaptation pipeline on their own traffic. Policy Align synthesizes policy-violating instructions from a natural language safety policy and performs on-policy self-distillation. An optional policy-sensitive filtering step selects high-impact examples for the distillation stage. It improves safety across multiple models while keeping over-refusal low and preserving general capabilities. The method also generalizes to medical, legal, and financial policies without requiring new preference datasets. Safety teams that receive new policies faster than they can collect preference data should test the released code. Okay, let's pop the hood on test time adaptation under distribution shift. Everyone talks about test time adaptation as a simple just keep learning switch. In practice, it is a semi-supervised loop that treats incoming unlabeled samples as a mini training set whose homogeneity supplies the supervision signal. The method first clusters recent inference examples, then uses high-confidence pseudo-labels within each cluster to update a lightweight adapter while freezing the base detector. This adds roughly 1 forward pass per batch but avoids any labeled data collection after deployment. The approach shines when the shift is gradual and the model family stays constant. It degrades when entirely new model families appear because the homogeneity assumption breaks. When facing repeated adversarial humanization or daily drift in user writing style, run the adaptation step on a sliding window of the last few hundred samples rather than the full history. So when should you actually reach for this versus the alternative? Use it for gradual drift within a fixed model family and skip it when new model families arrive. Test the new GPT-5.5 Instant on any multi-constraint prompts that previously required clarification turns to measure the intent handling improvement. Run your agent on the Agent Odyssey game generator to quantify how far its meaningful horizon extends before performance collapses. Apply the frozen 240 task production eval method from the Reddit post to the next model you are considering instead of relying on vendor benchmarks. Try the released bypass code on your current group-based RL agent setup if singleton groups are limiting credit assignment. OpenAI's Jalapeño chip is expected to enter production serving for ChatGPT and agent workloads in the coming months. More teams will release custom eval sets sampled from their own traffic distributions, following the pattern described in the Reddit discussion. Additional papers on test time adaptation for detection and agent memory are likely as distribution shift robustness becomes a standard requirement. Tomorrow, keep an eye on follow-up details around the Jalapeño chip rollout timeline and any new test time adaptation code drops. That's models and agents for today. If you found this useful, share it with someone who's trying to keep up with all these changes. And subscribe so you don't miss tomorrow's update. The AI world moves fast. We'll help you keep up. See you tomorrow. And before you go, this show is part of the Nara Network, a family of daily podcasts on tech, science, and markets. Each one a short, sharp briefing you can finish on the commute. If today earned its place in your feed, here's your next listen. Modern investing techniques, modern strategies for Canadian and US investors. Find every show free at naranetwork.com. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.